Okay, in this video clip I'm going to take a look at a paper from Mark Rubinstein, same Rubinstein of Cox-Ross Rubinstein, who developed originally the binomial tree. And an interesting article that was published in the Journal of Derivatives is related to implementing in the binomial framework skewness and kurtosis. So generally when we price options, we assume that the distribution of the return is normal with a mean of 0, standard deviation of 1, and that the stock price is well behaved sub degree. And what in this paper, what Mark Rubinstein tries to set out here is to take into account situations where we no longer just assume that the distribution is bell-shaped. And so I might just read, this paper develops a simpler technique for valuing European and American derivatives with underlying asset risk-neutral returns that depart from log normal in terms of pre-specified non-zero skewness and greater than 3 kurtosis, instead of specifying the entire risk-neutral distribution by the riskless return and volatility as in Black-Scholes cases. The distribution is specified by its third and fourth central moments as well. So what the Edgeworth binomial tree accomplishes is to take into account the fact that the returns can be skewed and can be kurtotic. And we know from many years now that the volatility smile of options demonstrates a kind of skewness. We talk about a volatility skew and we talk about a volatility surface. And this is just one approach to try and implement with specific measures of skewness kurtosis what the option value is likely to be. Now, to implement this paper, I take code from Fabrice Rouah, and I'll leave a link underneath. So if I can just invoke that for a moment. Okay, so I have some code here that I originally took from Fabrice Rouah, and I'll leave a link underneath the video, a hyperlink, so that you can find the same code there. And so basically what I'll set out here in this video is just an implementation of the Edgeworth binomial tree. It also, we're going to use the online GBD compiler, and reason why in this instance Fabrice included here reference to the Boost libraries. They're available in Visual Studio and all C++ compilers, but they're automatically available on the online GBD compiler. So we'll go to online GBD compiler, and it takes a second for that to open. I'll copy the code that we have just here, so we'll just make sure we've got it properly copied. So come up here, edit, copy. I'll go into the online compiler. I'll make sure the language specification is C++. I'll delete out existing code. I'll paste. Okay, and just take note of the parameter inputs. We're going to say the spot price is currently 30, exercise 25, risk-free rate 5%, time period is equal to 6 months, volatility 30%, skew kurtosis are given as normal, as skew is 1, kurtosis is 3, it's a 100-step tree, and the output I should get is for European call, European put, American call, American put for those parameter inputs. So I'll just execute. code, and that just takes a second, keeping in mind that the valuation here is invoking matrix, which is not normally available in Visual Studio, and we're using the boost libraries, which is, yes, can be made available in Visual Studio, but automatically available here in the online compiler. And I've got some results here, and we have European call, European put, American call, and American put estimates. Okay, so I will leave a link to the code in the online compiler underneath